this is Algebra 1, Lesson 73. We're going to talk about factoring the difference of two squares and probability without replacement. We're starting on page 298. Since each of the terms in the following binomials is a perfect square, x squared minus y squared, 4p squared minus 25, m squared minus 16, it's a perfect square because everything in the term can be we can find a square root for everything in the term. So the square root of this is x. The square root of this is y. The square root of this term is 2p. Because 2p times 2p is 4p squared. The square root of this is 5, m, and 4. So since each of the terms in the following binomials is a perfect square, these binomials are called the difference of two squares because we're subtracting. We can generate differences of two squares by multiplying the sum and difference of two monomials. So, for example, we can multiply x plus y times x minus y. We can multiply 2p plus 5 times 2p minus 5. We can multiply m plus 4 times m minus 4. These are called conjugates. When the variables are the same or the numbers are the same but the sign in the middle is different, it's called a conjugate. When we multiply conjugates, we get the difference of two squares. So let's try it. Y times negative y is negative y squared. Negative y times x is negative yx. Positive xy is positive yx. And x times x is x squared. When we add these together, this will be minus y squared. These two will cancel, they equal 0, and this will be x squared. So we get x squared minus y squared, the difference of two squares. Let's try this one. Negative 5 times 5 is minus 25. Negative 5 times 2p is negative 10p. 2p times 5 is positive 10p. And 2p times 2p is 4p squared. These two added together cancel, and we have 4p squared minus 25. Getting the idea? Let's try one more. Negative 4 times 4 is negative 16. Negative 4 times m is minus 4m. M times 4 is 4m, and that's positive. M times m is m squared. Added together, we have m squared. These two cancel. Minus 16. Now that we know this, we can factor the difference of two squares. So if we have 9m squared minus 49, we know that this is the square root of this plus the square root of this times the square root of this minus the square root of this. So the square root of 9m squared would be 3m. The square root of 49 is 7. So if we do 3m plus 7 and 3m minus 7, then we have the difference. Then we have the conjugates of the binomials, and multiplied together we get this. We can check this. So 3m times 3m is 9m squared. 3m times negative 7 is minus 21m. 7 times 3m is positive 21m. And 7 times negative 7 is minus 49. These two cancel, and we're left with this. Okay, here's just variables, but we can do it the same way. The square root of this is f. The square root of this is s. So we multiply these, that's an s, not a 2. these two variables together, sorry, as a difference of two squares, and it'll, the conjugates of these binomials together to get this difference of two squares. Okay, let's try it with this. We have -4 plus x squared. If we rewrite this, we have x squared minus 4. Okay, now we have the difference of two squares. So there'll be two binomials. The square root of x squared is x. The square root of 4 is 2. One will be negative and one will be positive. And that would be the answer. Here we have 49m squared minus a squared. The square root of 49 is 7. The square root of m squared is m, and the square root of a squared is a. So we have 7m and 7m. We have a and a. One will be positive and one will be negative. Okay? Here's another one. We have -36a squared plus 25y. If we rewrite this, we'll have 25y squared minus 36a squared. The square root of 25 is 5. The square root of y squared is y. The square root of 36 is 6. And the square root of a squared is a. So we have 5y and 5y. We have 6a and 6a. One will be positive, one will be negative. Okay, here's a crazy one. The square root of 36 is 6. The square root of x to the 6th is x to the 3rd. The square root of y to the 4th is y squared. The square root of 49 is 7. And the square root of a squared is a. And we can rewrite this so the negative one is second. So we have 7a and 7a plus and minus 6x cubed y squared. 6x cubed y squared. Okay, now we're going to talk about probability again. This time we're going to talk about probability without replacement. If we draw a marble from an urn and then drop it back in, this is an independent event, and the result of the first draw doesn't affect future draws. However, if we do not return the marble to the urn, the sample space changes for each successive draw. Alright, so here's an example. An urn contains 3 black marbles and 5 white marbles. A marble is drawn at random from the urn and is replaced. Then a second marble is drawn. What is the probability that both marbles are black? Okay, so probability is going to equal the number of marbles that fill this requirement. So we want the number of black marbles, and there are 3, and over the total number of possibilities. So in this case, there are 8 marbles in our sample space. So the probability that one marble is black is 3/8. Because we put the marble back in, these are independent events. So the probability that the second marble is also black is also 3/8. And now we multiply this together, and we get 9/64. And that was the probability of black and black. Right? Okay, so if the first marble was not replaced before the second marble was drawn, what is the probability that both of them are black? So if the marble was not replaced, the first draw, our probability is still going to be 3/8 because there were 3 black marbles in the urn and there were 8 marbles altogether. For the second draw, if the first marble pulled out was black, now there are only 2 marbles left in the urn, 2 black marbles left in the urn. So the probability of pulling one of those is going to be 2, because there are now 2 black marbles, and our total number of marbles in the urn has changed. There were 8, and now there are only 7. So the probability is going to be 6 over 56, which can be reduced to 3 over 28. Here's another example. An urn contains 4 red marbles and 7 blue marbles. 2 marbles are drawn at random. What is the probability that the first is red and the second is blue if the marbles are drawn first with replacement? So our first example is going to be, they pulled 1 marble out, it was red, they dropped it back in. And they pull another marble out and it's blue. So the probability of red and then blue with replacement. So we want the first one to be red. There were 4 red marbles in the urn. So our probability of the first one being red would be 4 over the total number of marbles, which is 11. Times, there are 7 blue marbles, so there are 7 chances for it to be blue out of 11, because we replaced the first one we drew. So our probability is going to be 28 over 121. Okay? Let's look at the second example. What is the probability that the first is red and the second is blue if the marbles are drawn without replacement? So the probability of a red marble and then a blue marble, the first time it's still going to be 4 out of 11. The second time there are still 7 blue marbles, but now there are only 10 marbles total in the urn. So the second time is going to be 7 out of 10. And we multiply that together and we get 28 out of 110, which can be reduced to 14 out of 55. So that's the probability of red and then blue without replacement. And that's it for this lesson. Try the practice problems. Let me know if you have any questions, and do all the problems from this lesson. Thank you.